In the previous video, we had learned about the four quantum numbers, the principal, azimuthal, magnetic, and spin. If you remember, when we spoke about the azimuthal quantum number, that is L, the value of L equals to 0 refers to S, and then 1 refers to P, 2 refers to D, and 3 refers to F. But like I didn't go in much detail about what that meant. So in this video, we are going to be learning about shapes of atomic orbitals. So they are basically atomic orbitals, right? So the orbital wave function, or that is psi, for an electron, it has no physical meaning. It's just a mathematical function. So when you have a coordinate or a graph that plots the wave functions and the distance from the nucleus, the graphs which are obtained for different orbitals are going to be different. So these are the graphs. So according to Max Born, the square of the wave function at a point gives the probability density of the electron at that point. So here, if you see, you have two sets of graphs. First of all, this is for 1s, these two are for 1s, and these two are for 2s. Here, these are psi versus r, whereas this is for psi square versus r. Now, in these graphs, if you notice, they are different for different orbitals. So 1s is different from 2s. So, according to him, for 1s orbital, if you notice, the probability of finding the density, that is finding the electron, is maximum at the nucleus, and it decreases as we move away from it. So close to the nucleus, as in r is basically the distance from the nucleus. So it is the least when it is the closest to the nucleus. Probability is the highest when it's closest to the nucleus, and it decreases when there is an increase in the distance. On the other hand, when we talk about 2s, here you have a sharp decrease, okay, and it goes to 0 and then again starts increasing. And then after it reaches this point, which is a small tiny maximum, it decreases again and approaches 0. Now, this region where the probability density function is reducing to 0 is called as the nodal surface. What is it called? The nodal surface or nodes. So for ns orbital, there are n minus 1 nodes. So as the number of nodes increases, with the increase in principal quantum number. So the number of nodes for 2s was 1, whereas the number of nodes for 3s would be 2. Now, boundary surface diagrams. So these basically are very important because they give us a basic idea or representation of the shape of the orbital. Okay, and over there, the value of the probability density, that is psi square, is constant. So many boundary surfaces can be formed, but the probability, so basically the probability of finding the electron is close to 90% within this boundary surface. But you need to remember that no matter how far we go from the nucleus, the value of the probability of finding the electron is never 0%. Because the probability density, that is psi square, is always going to have a value. So we cannot draw a diagram or the shape of the orbital as some rigid structure. Okay, it will have where the probability of finding the electron is going to be 100%. That's not possible, but you can get it to a certain extent, but it is highly probable of finding the electron. So let's start from the first, the s orbital. The boundary surface diagram is actually a sphere centered. So here you have in 2 dimension, it will look like a circle. And the probability of finding the electron is 90%. You need to notice that 1s and 2s and 3s, all these three are basically spheres. In 2 dimensions, however, they would probably look like circles. Okay, and the probability of finding an electron in a given point is equal in all directions. Also, The size increases with increase in the value of n. It's very obvious, right? Size of 1s is the smallest, 2s is slightly bigger, 3s is even more big. So this is about 90%. Also, I would, yeah. Next is p orbital. P orbital, unlike s orbital, they are not spherical. If you notice, they're not spheres, okay? But they have two sections which are called as lobes. So here, these areas, these pass through the nucleus, and the probability of finding the electron here is 0%. So this intersection point, it is going to be 0%. So the size, shape, and energy are identical, but their orientations are different. So you have px, py, and pz. It's based on the orientation along which axis. So this is along the x-axis, this is along the z-axis, this is along the y-axis. So similar to s orbital, when you have the increase in size, the orbital size is also, increase in the principal quantum number, the orbital size is also going to increase. So 4p is bigger than 3p, which is bigger than 2p. Now, it also so the probability density functions for p orbital, it also passes through the value 0. If you remember, we had spoken about the probability function versus r. For s orbital, for 2s, you had one node. Similarly, for this also, you have nodes which are given by the value n minus 2. So for 3p orbital, it has one radial node, and for 4p, it will have two nodes. So in that graph, you'd get two nodes for 4p and one node for 3p. That is the main difference between p and s. Now, in case of d orbital, where here L equals to 2. So this orbital has a minimum value of principal quantum number will be 3. So only from the 3, that is the principal quantum number 3, you will have d orbital coming in. So it has 5 different ml values, -2, -1, 0, +1, and +2. So they have 5 orbitals. So here, if you see, you have 1, 2, 3, 4, 5. 5 orbitals in the D atomic orbital. So they are designated as dx square minus y square, dxz, dz square, dyz, and dxy. So this is also with respect to the plane in which it is in. Okay, so it is different. So the first 4 orbitals are similar to each other. If you notice, these 2, 1, 2, 3, and 4, these 4 are quite similar to each other, but dz square is different from the others. But they all have equal energy. All the d orbitals will have equal energy, and when the value is greater than 3, so as you have increase in the principal quantum number, the size of the d orbital is also going to increase. Okay, so in this, there's one more important thing I wanted to talk about. So radial nodes is basically the probability of finding the electron is low. Okay, it's basically 0. So here we need to remember that the total number of nodes is given by the equation n minus 1. So that is nothing but n minus 1 minus L is the number of nodes that is present or that is given by a particular orbital. So in this video, we learned about the boundary surface diagrams and the shape of orbital. In s orbital is spherical, p has 2 lobes, d has variation in shapes, but all of these, you need to remember that the shape of the orbital, despite it being different from each other, when we talk about s orbital, 2s, the size of 2s will always be bigger than 1s. 2p will be bigger than 3p will be bigger than 2p, and 4d will be bigger than 3D. So the size of the orbitals is going to increase as as the principal quantum number increases. Notice we are not talking about the comparison in size between two different orbitals, as in 2s and 2p. Okay, we're only talking about the same type of orbital, how it increases in size as the principal quantum number increases. In the next video, we will be learning about the rules, the various rules that are followed for filling up of the electrons.